Welcome back. This is Mr. Tipton, and today we are converting repeating decimals. We've been studying real numbers, talking about rational versus irrational numbers, and how rational numbers are numbers that can be written as fractions. Repeating decimals are rational numbers. There is a way to write them as fractions, and that's what we're going to talk about doing today. The big thing that's going to help us today is what I've written here in green. The number of digits under the bar is the power of 10 that you multiply by. That doesn't mean anything to you yet, but it will when we jump into our examples. The number of digits under the bar is the power of 10 that you multiply by. In our first example, we've got 0.3 repeating. Now, most of us know that 1/3 is 0.3 repeating. What I'm going to do is show you how that works mathematically, not just because I've memorized it. We need to start by making 0.3 repeating into an equation. So we're going to put n is equal to 0.3 repeating. What we're going to be doing is setting up what's called a system of equations so that we can convert this number. All right. Now our rule: the number of digits under the bar is the power of 10 that you multiply by. There is one digit underneath our repeating bar. Of course, we know that the repeating bar means we actually have 0.3333333 forever. But what we're going to do is, because there's one digit underneath the repeating bar, we're going to multiply both sides of this equation by 10 to the first power, because there's one digit under the bar. 10 to the first power is 10. Here's what this is going to look like. When we multiply the left side by 10, we have 10 times n, or 10n. When we multiply the right side, the decimal moves over one place because we're multiplying by a power of 10. So what we actually have is 3.3 repeating. The only thing I've done for this second equation that's on top here is I multiplied both sides by 10. 10 to the first power, because there was one digit underneath the repeating line. Now I've got a system of equations. I've got two equations that really they represent the same thing. They're just, one was multiplied by 10. What I'm going to do with this system of equations is I'm going to subtract the first one from the new one. 10n minus n, or really this is 1n. 10n minus 1n is 9n. And on the right side, these three repeatings, they're going to cancel out because they're subtracting. 3 repeating minus 3 repeating, nothing. Anything minus itself is 0. But we still have the 3 minus 0, which is 3. And then to get n by itself, we're going to divide both sides by 9, and we end up with n is equal to 1/3, which we already knew. We knew that 1/3 is 0.3 repeating, but now we know mathematically how to convert that repeating decimal back into a fraction. Let's look at another. 0.7 repeating. Again, I'm going to start out making it an equation. N is equal to 0.7 repeating. And we know that means 777777777 forever. There's one digit under the bar, so we're going to multiply both sides by 10 to the first, which is 10. 10 times n is 10n. And on the right, 0.7 repeating times 10 to the first gives us 7.7 repeating. And now we're going to subtract our system of equations. 10n minus 1n gives us 9n again. And our repeating decimals cancel. 7 minus 0 is 7. Divide both sides by 9 to get n by itself. And that's our answer, 7/9. You could put 7 divided by 9 in your calculator and hit enter, and you would get 0.777777 forever, 0.7 repeating. Alright, let's do another one. 0.12. What's different about this one is this time we have two numbers under the repeating bar, which means we're going to be multiplying both sides by 10 to the second power, which we know 10 times 10 is 100. Alright, 0.12 repeating is 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. You get the idea. Let's multiply both sides by 100. On the left, we get 100n. And on the right, we're moving over twice. Because it's 10 to the second power, we're going to get 12.12 repeating. Still, we're going to subtract. 100n minus 1n is 9n. Oh, I'm sorry. 100 minus 1 is 99n. And on the right side, the 12 repeatings cancel. 12 minus 0 is 12. Divide both sides by 99, and we are left with n is equal to 4/33. If you put 4 divided by 33 in your calculator, you would get 0.1212121212. Alright, next example. This one's a little different. If you'll notice, there are two digits in this number, 0.15 repeating, but the bar is only over the 5, so it's just the 5 that repeats. It's not 151515. Look at the last one. The last one was 1 2. We're both under the bar, so we repeated 1 2 1 2 1 2. See the difference? There's one number underneath the repeating bar, so we're going to multiply both sides by 10 to the first power. On the left side, we get 10n. And on the right side, we multiply by 10, we come over 1, and we're going to get 1.5. Now, pay attention to this. Here's where it's a little different. I need my 5 repeatings, my repeating 5s to cancel. Alright, I know that this 5 is going to repeat, so technically there are 5s out here forever still. But just so it makes a little more sense for me to line up my subtraction, I'm going to put one more 5 out there. And I'm going to put my repeating sign over that. Okay, that's not normally how we write repeating decimals. You're supposed to put the bar over the earliest, simplest pattern, but for converting, we're going to make an exception. Alright, I'm ready to subtract them now. 10n minus n is 9n. And on the right side, I've set it up so that my repeating 5s are going to cancel. Then 1.5 minus 0.1 is 1.4. I still need to get n by itself, so I divide both sides by 9. But here's the problem. We can't have a decimal inside a fraction, which is no problem. We're just going to multiply the top and the bottom by 10 to get rid of that decimal. Alright, let me switch colors again. We multiply by 10 and the decimal comes over one place. We multiply by 10 and the decimal comes over one place. So we end up with 14/90ths, which still can be reduced to 7/45. Alright, so a few more steps in this one because there were two digits, but there was only one of them underneath the repeating bar. So had a couple extra steps in there. And I think, yeah, that's the last example that I did. But if you have questions over anything we did in this video today, write them down and come to class ready to talk about it. See you soon.